Hey guys, Mr. Mills here. We are going to talk about some trigonometric identities today. So I'm going to introduce a few formulas that we're going to use here in the coming days to solve some problems and evaluate some expressions and simplify some equations and things like that. So the first few that I'm going to introduce, these ones should be pretty familiar to us. These first ones are going to be called the reciprocal identities. Reciprocal identities. And these ones we have seen before. So these are kind of like the six main ones, right? So the sine of theta equals 1 divided by the cosecant of theta. The cosine of theta equals 1 divided by the secant of theta. And the tangent of theta equals 1 divided by the cotangent of theta. And of course we have them the other way around, so the cosecant of theta equals 1 divided by the sine of theta. The secant of theta equals 1 divided by the cosine of theta. And then of course the cotangent of theta equals 1 divided by the tangent of theta. Let me make this a little bit bigger. Okay. So these are the reciprocal identities that we're going to eventually need. Two more that we have actually seen before are the quotient identities. And I'm sure these are also familiar. So there's two of these guys. So, you know, the tangent is always defined as sine over cosine. So the tangent of theta equals sine of theta over cosine of theta. And then the cotangent of theta equals the cosine of theta divided by the sine of theta. So kind of flipped there. So these 8 we have seen before. There are a couple more, which of course can be derived. So I'm going to derive one of them real quick over here. So if you remember way back when we did unit circle stuff, way back then, sketch a little circle here. So if you remember, when we did, we called sine of theta was always y over r, right? But on the unit circle, we said r was just 1, right? Because the unit circle has a radius of 1. So that means that the sine of theta is just y. You could also say that the cosine of theta is just x. Okay, and so what I can do on my unit circle here is let's pick a random point right here, and we'll draw this triangle. Okay. So here is my unit circle with my point on the arc over here, and this is the point x comma y. Right. Well, this is x comma y, so I don't know the distance here on the x-axis, so I'm just going to call that guy x. And then again, I don't know the height there, so I'll just call that y. So if I'm looking at, put theta right there in the corner where it should be. If I'm looking at my unit circle here with sine of theta being y and cosine of theta being x, and of course I know that my radius here is 1, then I can apply my Pythagorean theorem, right, way back in geometry, a squared plus b squared equals c squared. I can apply that here where I have x squared plus y squared equals 1, right? X squared plus y squared equals 1. But truly, I mean, what is x? Well, x is the cosine of theta, and y is the sine of theta, right? So I can substitute cosine of theta in for x, and I can substitute sine of theta in for y, right? So cosine squared of theta plus sine squared of theta equals 1. And this is actually going to be one of my identities here, and I'm going to call this my Pythagorean identities, just like Pythagorean theorem. Oh, sorry about that. Okay. My Pythagorean identities, having troubles here. Pythagorean identities, and there's going to be 3 of these guys. So we went ahead and just derived that first one there. So cosine of theta, cosine squared of theta, sorry, plus sine squared of theta equals 1. That's our first one. We have 2 more that we're going to use, and so one of those is the tangent squared of theta plus 1 equals the secant squared of theta. And then lastly, the cotangent squared of theta plus 1 equals cosecant squared of theta. Okay. There are actually a bunch of different Pythagorean identities. We really just use these first 3. Of course, remember that tangent squared of theta plus 1 equals secant squared of theta. And then the last one. These could also be derived, just like we did over here. Just for the sake of time, we only derived the first one. Okay. So we have our Pythagorean identities. We're going to use 2 more identities. I'm not going to derive these ones. So one of them is going to be the cofunction. Ooh, fancy. The cofunction identities. These are really just a bunch of phase shifts. So the first one is going to be the sine of pi over 2 minus theta equals the cosine of theta. Right, just a little phase shift going on there. The second one is going to be the cosine of pi over 2 minus theta equals the sine of theta. And then third is going to be the tangent of pi over 2 minus theta equals the cotangent of theta. Whoops, I forgot some parentheses here. All right, so right now I have 4 different sets of identities. I'm going to go ahead and do one more. This last one's not too bad. I'm going to call this the negative angle identities. The negative angle identities. And these ones, again, could be derived. Maybe we'll do that in the future. So the sine of negative theta actually just equals negative sine of theta. Pretty convenient. We also have the cosine of negative theta. This one's our best friend. Cosine of negative theta actually just equals positive cosine theta. So that's nice. And then last, the tangent of negative theta equals negative tangent of theta. And these could be applied to their reciprocal identities, but we're really just focused on the 3 main trig functions, sine, cosine, and tangent. Okay. So what I'm going to do now is I'm going to walk through one example here with these all of my formulas, and I'm going to try to use one to evaluate an expression. So let's see here. So let's find the exact value of cosine of theta if the sine of theta equals 1/4 and if theta is between 90 and 180 degrees. So find the exact value of cosine of theta if sine of theta equals 1/4, and theta is between 90 and 180 degrees. So what does this last part mean here? Right? That means that if I look at my xy plane, that means that theta is going to land somewhere here in the second quadrant. All right, so right somewhere around right here is theta. And that's because if we were in the first quadrant, well, that'd be less than 90. And if we're in the second quadrant, of course, that's between 90 degrees up here and 180 degrees on the axis. Okay. So I know theta is going to be, we're going to be in that second quadrant there. This is going to be useful in a minute. So let's see here. I'm given that the sine of theta is 1/4, and I need to find cosine of theta. Okay. So if we look back at our Pythagorean identities up here, we have this top Pythagorean identity is the cosine squared of theta plus the sine squared of theta equals 1. Okay. So down here, I'm given that the sine of theta is 1/4. So I can use this identity, cosine squared of theta plus the sine squared of theta equals 1. And I can substitute in this sine of theta equals 1/4. I can substitute that in for my sine of theta here, right? So when I sub that in, I get the cosine squared of theta plus sine of theta is 1/4. So this is plus 1/4 squared, and that still equals 1. And I can just go ahead and simplify this guy, right? So cosine squared of theta plus 1/16 equals 1. Subtract that 1/16 to the other side, so cosine squared of theta equals 1 minus 1/16. And that guy, we can just reduce that. So cosine squared of theta equals, that would be 15/16. Okay. And then when we take the square root of both sides, we're going to get the cosine of theta is going to equal, remember whenever we take the square root, you got to do plus or minus. So plus or minus the square root of 15 divided by the square root of 16 is nice. It's just 4. Okay. So that means our answer is either going to be positive root 15 divided by 4 or negative root 15 divided by 4. And so the question is, do we have positive 15 over 4, or do we have negative root 15 over 4? Well, if we think back to where theta is in the second quadrant, right? So if we are in the second quadrant right here, is cosine going to be positive or negative in this second quadrant? And if you remember, all students take calculus. If theta is in the second quadrant, then the only trig functions that are positive over here are sine, right? Sine's positive, and of course its reciprocal, secant. But cosine is negative in this quadrant. So that means my answer here, when I have to determine if it's the positive value or the negative value, we're in the second quadrant and cosine is negative there. So that means cosine of theta is going to be negative root 15 over 4.